Hi class, welcome to lesson 17. In this lesson, we're going to study the combined gas law. By the end of this lesson, you should be able to convert between units of temperature and determine the relationship between temperature, volume, and pressure of a gas in a sealed container. Make sure you take notes. You have a Regents Chemistry reference table and a calculator. Let's get started. The first thing we are going to look at are the factors that affect the behavior of a gas. The factors that affect the behavior of a gas can be found in the combined gas law on reference table T. So those factors include volume, temperature, which must be measured in Kelvin. Recall that the Kelvin temperature is equal to the average kinetic energy. The amount of gas particles when we use the combined gas law must be held constant. That means all of our gases will be in sealed containers. That way, no gaseous particles will be added or removed from the system. Some examples of sealed containers of gases include balloons, bike tires, basketballs, and syringes that have a cap on them. The last factor that affects the behavior of a gas is pressure, which could be measured in either atmospheres or kilopascals. The relationship between pressure, temperature, and volume is described by the combined gas law, which you do not need to memorize, but you do need to know how to find it on reference table T. It's very important when solving equations using the combined gas law that you always remember that the temperature must be in Kelvin. This way we will avoid negative values. You can find the equation to convert between Kelvin and Celsius temperatures on reference table T. Make sure that your units for pressure and volume are the same, meaning if V1 is measured in liters, V2 must also be in liters. But if the first volume is measured in milliliters, then the second volume will also be measured in milliliters. The same is true for pressures. So if one pressure is measured in atmospheres, the other pressure must also be measured in atmospheres. Lastly, if one variable remains the same or constant, you can eliminate it. So by now you should be able to convert between units of temperature. Make sure you have out your reference table and calculator, as I'm going to walk you through 4 examples of how we can use the combined gas law to predict the behavior of gases under changing conditions. So in this word problem, what we're going to first do is set up a variable table. So I'm going to list the variables that I need from the combined gas law equation found here on reference table T. Now that I have my variables, what I'm going to do is carefully read and substitute. A sample of helium gas has a volume of 0.180 liters. This is a volume, and it's the first volume that we encounter. So this must be V1. A pressure of 0.800 atmospheres. This pressure is the first pressure we encounter, so it's P1. And a temperature of 29 degrees Celsius. What is the new temperature? So we're looking for T2 of the gas at a volume of 0.090 liters. So liters if you're unsure of which variable corresponds with liters, if you look on reference table D, you'll see that the liter, you'll find the liter, the L here, that is a volume. So when we go back to reference table T, you can see that the volume is V. So that's our V2. So again, as we're reading, we have this many liters. So that is V2. And we have a pressure of 3.2 atmospheres. Now that we have our variable table up, we're going to refer to the equation on reference table T. Again, it's the combined gas law equation right here, and we're going to substitute. Now, before I put the temperature in, remember that the temperature has to be in Kelvin. So I'm going to have to add 273, and how I know that is down on my reference table. You can see that the temperature conversion here, that Kelvin is Celsius plus 273. So that means that my temperature is actually 302. So I'm going to make sure that I only substitute the Kelvin temperature. And then when I use the other values to substitute, and I'm looking for the new temperature. So I can call this T, or you can call it X. Any variable you like will work. From here, we have an algebra problem. You can solve this a number of ways, but I like to cross multiply, meaning I'm going to put these values together and multiply them and set them equal to these values together. And I'm just going to use my calculator to do that. I always have my non-graphing scientific calculator, and I'm just going to input these values. So when I multiply the 0.800 times 0.180 times X, what I'm going to get is a value of 'So T is my variable, and now I'm going to multiply what's here in green, so in this diagonal, and I'm going to get this value. Now to solve, we're going to divide both sides. By this value, so I can isolate the T. And now I'm going to get X equals 604. Now my unit in here is Kelvin, so it's 604 Kelvin. But they wanted to know, what is the new temperature in degrees Celsius? So one more time, we're going to go back to our reference table for the temperature conversion equation. And I see that Kelvin equals Celsius plus 273. So from there, in order to get C by itself, we'll subtract 273 on both sides. And here, our Celsius will equal, so this is my answer. The first step is to set up your variable table. And so as we read, consider a 3-liter sample. Remember, liters is a volume. This is the first volume of gaseous sulfur dioxide at a pressure of 1 atmosphere. If the pressure is changed to 1.5 atmospheres, so that's a second pressure, at constant temperature. So here, when we see at constant temperature, it means we can remove the temperature variable. What will be the new volume of gas? So what we can do is, this is X. So when we go back to the combined gas law equation, we're going to eliminate the T's. So let me show you. So since temperature is constant, we can remove it. So our equation becomes P1 times V1 equals P2 times V2. From here, we're going to substitute. Always using your non-graphing calculator, we're going to solve. Here we get x equals 2.0. For sig figs, we're going to have 2 significant digits. And now we need a unit. So our unit is for volume. Since our original volume is liters, our new volume is also liters. So this is 2.0 liters. Let's try another question. Again, our first step is to set up a variable table. A gas with a volume of 4 liters. That's the first volume. So I'm just going to substitute. At STP, what is its volume at 2 atmospheres? So STP is both a P and a T. We'll come back to that. So what is the volume of 2 atmospheres? So the second pressure is 2 atmospheres. We have a pressure of 2 atmospheres at 30 degrees Celsius. So our temperature here is 30 degrees Celsius. And we're looking for the volume. So V2 is X. Before we can substitute, we have a couple of things we need to do. First, we have to find what is P1. To find P1, we're going to have to find STP. STP is in reference table A. Now, STP has 2 pressures. One of the pressures is 1 atmosphere, and the other pressure is 101.3 kilopascals. So which one do we pick? Well, since our P2 is in atmospheres, we should pick the pressure that is in atmospheres. So we're going to pick 1 atmosphere. Again, it's important to make sure your units match. So I have atmospheres are both of my pressure readings. Now for temperature, it's important to remember the temperature must be in Kelvin. So I'm going to choose 273 for the first temperature, and I'll need to calculate the second temperature. Now that my variable table is established, I can substitute into the equation from reference table T. So from here, we can use cross multiplication to solve. So again, we can multiply these items on this diagonal and set them equal to these items on this diagonal. That gives us now we need to solve for v. To get v by itself, we're going to divide on both sides. And my calculator gives me this number. Now, due to significant digits, this has only 2 digits, I'm going to round this to 2.2, and the unit should match. So the unit is liters. That was a tricky one. Hopefully you got it. By now, you should be able to determine the relationship between temperature, volume, and pressure of a gas in a sealed container using the combined gas law. We have now reached the end of lesson 17. You should be able to convert between units of temperature and determine the relationship between temperature, volume, and pressure of gas in a sealed container using the combined gas law. This marks the end of lesson 17. Make sure you've taken good notes. Write down any questions you have and ask them in class. Complete your homework on Google Classroom and put your Regents Chemistry reference table and calculator back in your backpack so that you are prepared for class. I'll see you soon. In this final example, again, we're going to start with a variable table. A gas in a rigid container. Now, rigid means that the gas container cannot expand or contract. Has a pressure of 3.5 atmospheres. The first pressure is 3.5. And the first temperature is 200 Kelvin. Calculate the pressure, so the second pressure is X, at 273 Kelvin. Now, notice they didn't mention the volume. Back to the word rigid. Rigid means the volume cannot change. So since volume is not mentioned and our container is rigid, we can remove volume from this equation. So if we start with the equation from reference table T, and we remove the volumes, we are left with P1 divided by T1 equals P2 divided by T2. So let's substitute. Solve by cross multiplying. Multiply what's in green and set it equal to what's in this awesome purple pink color. Again, make sure you're using your non-graphing calculator. So here I would get that my X equals, now when I look back here, this only has 2 digits, so I can round this to 2 digits. And my pressure, because my one pressure is in atmospheres, my new pressure is also in atmospheres. So hopefully you get how to solve equations using the combined gas law. It's just simple algebra.